Today's lesson is on adding mixed numbers, and specifically it's mixed numbers with unlike denominators. There's a lot of steps involved here. This goes along with lesson 8-7 of Scott Forsman Math, and our objective today is to add mixed numbers with unlike denominators, and we're going to do that by finding the least common multiple, adding, simplifying, and then simplifying sometimes means that you're going to have to be able to convert improper fractions to mixed numbers and then combine like terms, whole numbers combined and then fraction pieces combined. And like I said, there's a lot of steps to this. Since there's a lot of steps, there's a lot of previous knowledge that goes into it. So in order to succeed in this lesson, you're going to have to know how to simplify fractions, find least common multiple, convert equivalent fractions, then change or convert improper fractions to mixed numbers and mixed numbers to improper fractions. You're going to have to know how to add mixed numbers, and there's one kind of tricky part to that. And then the vocabulary is the same as it has been for just about all of Chapter 8. Numerator, denominator, mixed number, and improper fraction. So if you're at all unclear with any of these things, or you need a little bit more review, please review those before you continue with this lesson. Here's our notes for today. There's actually two of them that I want you to get down. Remember, label on the right, hole punch on the left, and then the first thing is, how do I add mixed numbers with unlike denominators? Like, what are the steps in all of that? And then I'm going to say combine like terms a couple of times, so I want you to know, what does that mean? It's actually pretty simple. All right, here's the knowledge we have to have. There are several steps to each problem, right? And you're going to be adding and finding least common denominators and combining all the things that are alike. That's what like terms means. And you might end up with something like this. And you may remember this from the previous lesson on adding mixed numbers, but this is just a refresher. So when you have a mixed number that contains an improper fraction, you have to be able to see that as, well, here's the fraction part and here's the whole number part, right? And I can't have an improper fraction, so I'm going to be simplifying that fraction to make sure it's in its simplest form, and that requires you to write it in a mixed number. So 10, you're dividing that into 14, so it's times 1. So 14 tenths equals 1 4/10. The right color here. 1 4/10, and then the 3 part of that stays. Again with the right color. And now we have 3 equals 3 and 14 tenths equals 1 4/10. And now here's what it means to combine like terms. This does not equal 31 4/10. That's 3 and that's 1 4/10. And so the terms that are the same need to be combined, which means the whole numbers are one term, the fractions are another term. So whole numbers combined equals 4, and then the fraction parts 4/10. Now here's the tricky part. People are going to forget that after you do all of that, that still needs to be simplified. So you need to find the greatest common factor and simplify. Over here, same thing. We have a couple of different fractions. We have the whole numbers over here, and then the fraction pieces over here, and we need to turn that improper fraction into a mixed number. That's 30 divided by 24. The whole number is 1, and then how many pieces do we have left over? 6 24ths. So we have 5, and then this is 1 and 6 24ths. And again, we're going to kind of see those things as different. This is one term, and this over here is another piece, right? But combining like terms means I'm going to combine the 5 and the 1 to make 6, and then the 6 24ths. And then again, it's very sneaky, but we have to simplify that fraction at the end. And please see that, at the end of everything, look at the fraction part and simplify if you can. All right, here's our first example problem, how to run it through it the whole way. And normally I solve fractions in a horizontal method. The vertical method for solving mixed numbers with improper fractions works pretty well. So I'm going to show you that method now. 4 2/3 plus 1 1/4. So if I write 4 2/3, and then vertical means up and down, so if I write 1 1/4 right under it, I can add them like that, because it's going to give us more room over here to convert each one of these fractions. All right, so we have a fraction with a denominator of 3 and a fraction of the denominator of 4. So I need to find the least common multiple now in order to find our new denominator, what they have in common. So we have least common multiple of 3 and 4. That's 3, 6, 9, 12, and I'm pretty sure it's going to be 12. So let's just prove it. 4, 8, and 12. There we go. So now this fraction and that mixed number and this mixed number are going to be equal to something with a denominator of 12. Just make sure that the whole numbers come with it. Okay, so I'm not just going to write the fraction over here. I write the fraction with the whole number just to make sure it stays. All right, so now it's equivalent fraction time, and that would be a times 4. 3 times 4 equals 12. Multiply the numerator by the same thing, so it's 4 8/12. And then on the other fraction you have 1, right, and something with a denominator of 12, and that would be 4 times 3 equals 12. 1 times 3 equals 3. So it gets a little messy in here, but you have to kind of maintain your focus and try to figure out what's going on there and not leaving any parts out. So now it's combining fraction parts. 8/12 and 3/12 equals 11/12. 4 whole numbers plus 1 whole numbers, again combining like terms. The wholes get combined, the 12ths get combined because they are alike. And the answer 5 11/12. How do I know that's in its simplest form? Well, the numerator is 1 less than the denominator. Anytime they are one number apart, you're in your simplest form. So what do? We first found the least common multiple, and then number 2, we converted the fractions to equivalent fractions. Number 3, combined everything, so we added. And then number 4, at the end, simplify. But in this case, it was already written in its simplest form. But again, those are the steps, and the same steps that we did for fractions, just knowing that here you have to add the whole numbers and the fraction parts. All right, here's an example problem where we're going to get a fraction that equals more than 1. So let's take this on again, and again writing it in the vertical method. The last time we wrote this in the vertical method, or last time I did anyway, I kind of ran out of space, and so maybe I'm going to leave myself a little bit more space here. All right, and we're adding those. First step, least common multiple of 8 and 4. I'm pretty sure most of you already know it's going to be 8, but let's just prove it. So the multiples of 8 are 8, 16, and so on. Multiples of 4 are 4, 8, 12, and so on. So here we have our least common multiple. So now we're converting each fraction to an equivalent fraction with a denominator of 8. This one already has a denominator of 8, but I'm going to rewrite it over here just to give myself a new problem, right? So I'm not adding something over here with something over here or vice versa. Now 1 1/4 equals 1 and something with a denominator of 8, and so we have to figure out that's times 2, right? And so on the top, 1 times 2 is 2. And at the end, it's combining everything. So now I have 7/8 plus 2/8 equals 9/8. And then 3 plus 1 equals 4. And this is one of those situations where you have fraction parts and you have whole numbers. So I'm trying to highlight with yellow, and you can't see the yellow there. So this fraction now needs to be turned into a mixed number, right? So 9/8 equals the right color. That's 9 divided by 8, which equals 1 and 1/8. All right, so this number right here, 4 and 9/8, equals 4 plus 1 and 1/8, and then combining everything, it's 4 and the 1 combined, like terms, and the 1/8. So this equals 5 and 1/8, and how do I know that's in its simplest form? The numerator is 1. All right, here's a couple of guided practice problems. I'm going to go through these as quickly as I can here. So writing the problem, you get 2 2/3, and then 5 1/6. Finding the least common multiple of these things. So LCM of 3 and 6 goes 3, 6, and I already know the first multiple of 6 is 6, so looks more like an, okay, now it looks like 6. So this one equals 2 and something over 6, and this one already has a denominator of 6, but I just want to write it in there anyway. So on the top fraction part, it's denominator 3 times 2 is 6, so 2 times 2 equals 4. And I'm used to writing in those lines, and if you're still used to writing in those lines, write them in. Eventually, this can be handled in your head. So at this point, it's combining all the things that are the same. The whole numbers are the same, so it's 2 plus 5 is 7, and then fraction parts 4 plus 1 equals 5/6. How do I know that's in its simplest form? I think you know by now. Here's our second guided practice problem, and it's 8 7/10, and we're going to add that to 5 3/5. We have to find a common denominator between 10 and 5, and so we do that by finding the least common multiple. Do that right over here. Least common multiple of 10 and 5. Okay, the multiples of 10 are 10, 20, 30, and so on. And the multiples of 5 are 5, 10. And by now you should be recognizing if the denominators are 5 and 10, then the least common denominator is going to be 10. So this fraction up here, 8 7/10, it's already with a denominator of 10. Don't need to do anything with that other than rewrite it so that it will go perfectly with our new fraction. So this is 5, and how many tenths? Well, that's a times 2 on the denominator side, so it must be times 2 in the numerators, and there we have our rewritten problem. Now 7/10 plus 6/10 equals 13/10, improper fraction, right? We're going to have to deal with that in a second. And then 8 plus 5 equals 13. So it's 13 13/10. Well, you can't have an improper fraction and think that that's the simplest form. So what do? It's dividing time. That's numerator divided by denominator. So I had 13/10. I make 10, or take 10 tens, 10 of them, not 10 tens, 10 13ths out to make one whole. So I've used 10, and how many tenths do I have left? 3 10ths. So 13 3/10 equals 13 1 3/10. Combining those two together, it becomes 14 3/10. And here's our task for today. We're working out of the homework book. That's H8-7, and we're doing problems number 1 through number 10. We're doing all of those. Just a reminder, after you regroup, you have to sometimes simplify. Good luck.